Well, good afternoon, everyone. I am here today to talk about threat modeling, one of my favourite subjects, and simplicity, which is something that I think sort of interests a lot of people, and how those two things are going to combine to hopefully improve the way that we can do threat modeling. I am a security architect, a former pen tester. Generally, I just like to think of myself as a bit of an engineer, really at heart. I've been doing security for a long time in many different places, but for the past several years, a lot of my focus has been spent on threat modeling. And I really got into threat modeling but after being a pen tester because I tended just to see the same issues over and over again. And threat modeling sort of appealed to the engineer in me because engineers like to create solutions to recurring problems. And I wanted a solution to the problem of seeing the same sort of security issues over and over again. And threat modeling really offers that solution because it helps to identify those issues that should be really solved by design, which then leads to those issues becoming rarer and rarer. But threat modeling has some challenges. It's a manual process. And to scale manual processes, you usually need a lot of people. So something like a security champions program can definitely help. But even so, the process of threat modeling really needs to be as accessible as possible. It's sort of like putting on this conference, right? It's a huge logistics exercise to get everyone in the same room together. But at the end of the day, you can't forget that you still need to deliver really interesting talks. And it's like this with many security activities. A security champions program will really help the logistics of rolling out that security activity to lots and lots of different people in the company. But the activity itself still has to not suck, right? It still has to be good, it still has to do what you want it to do. Now, in my opinion, one way to make threat modeling more accessible is to keep it as simple as possible. But what does simple really mean, right? So this talk is about how to leverage simplicity to make threat modeling an activity something that more people are likely to come back and do. So, what is simple? How do you know if something is simple? How do you make something simple? These are the sorts of questions that I asked myself when I was trying to decide if the decisions I was making around threat modeling were actually good decisions that were, made threat modeling easier for people while also delivering value, and that would enable the process to operate at scale. And I thought these were questions without obvious answers. I was relying on trial and error, and I certainly wish there was an easier way to find some of these answers. That's when I came across this guy, George M. Whitesides. I'm going to call him the chemist. Google Scholar has him as something like 200 research papers. He's been quoted in other scientific papers like 500,000 times, 100,000 times in the last year. He seems like a pretty clever guy by any measure. And he did a TED Talk called Towards a Science of Simplicity, and I would encourage everyone to go and see the TED Talk. It's really interesting. And in this talk, he talks about, what makes something simple? He talks about how the scientific community has studied complexity quite a lot, but has spent a lot less time really understanding what it is that makes something simple. So he offers up a way to think about simplicity based off his experience. Now, I was really blown away by this talk because I'd never really come across anything that had really helped me to think about the decisions that I made for threat modeling or about a way to evaluate other processes for simplicity. I watched this talk and thought, wow, I can definitely understand how a lot of what he talks about applies to threat modeling, which is kind of bizarre because I put money on the fact that this guy has probably never even heard of threat modeling. So if a chemist who studied dozens of areas of science has come up with some sort of framework that I think is applicable to a totally different area, then I think there's something in this. It was something worth exploring anyway. So what I'm going to cover then, very briefly, is a small part of what he covered in the TED Talk, and then also the properties that he came up with, that he identified that make something simple. I'll then try and repurpose those properties into more of a framework so then we can use them to evaluate or how simple something really is. So the first question posed by the TED Talk is, what does simple mean? And it turns out it's not an easy question to answer. You can think about it in different ways. You can think about something as being simple in construction. So spaghetti bolognese was probably one of the first meals I ever learned to cook, just because it's a simple place to start. It's kind of easy to make. You can think about something as being simple in purpose. So a book, whilst it can contain lots of complicated information inside, its purpose is quite simple, just to convey information to people who read it. And then you get something like a touchscreen tablet, which is simple in functionality. And this is quite interesting because it's very much in contrast to the other ones, right? Because a tablet is not simple in construction. It's very complicated to build a touchscreen tablet. It's not particularly simple in purpose because it can be used for so many different purposes. Yet it is quite simple in functionality because you could give it to a child and they could figure out how to use it in many ways. So you have these very differing ways of looking at simplicity, and these are just 3 examples of how you could view simplicity. It's by no means exhaustive. It's just meant to illustrate the difference. Now, even if you took one of those and said, right, well, I'm only interested in simplicity in construction, for instance, context still matters massively. If you take, by example, a cup, right? By all sort of intuitive measures, this is a simple thing. Certainly, if you think about it in construction, purpose, and functionality, because it consists of just like a holder and a handle, its purpose is to hold liquid, and it's, how do you use a cup? Well, it's pretty straightforward. So a cup, you would think, well, this must be simple. This must be a good example of something simple. But of course, you start to think about it. Simple for who? Not everyone can use a cup. So, you need to take that into account. Simple for when? Yes, I can take it on board a ship, but if the seas get too rough, suddenly it's a very poor solution for something to drink out of. And then sometimes you can think of situations that are just fundamentally violate what a cup needs, like gravity, in order to work properly. So you take all these together, and the reality is you're unlikely to be able to ever point at something and be like, that is definitely simple, or at least in a context-free sense. Context will always matter. And I would say that ultimately this means there's no simple definition of simple. There's sort of amount of irony there, I get it. But all hope is not lost, right? Our good friend the chemist tells us there are some properties that are actually shared amongst simple things. These properties don't really give us a definition of simple, but they certainly give us a place to start, to be a little bit more scientific about simplicity. So what are these 4 properties that the chemist is telling us about then? So the first is cheap, right? A simple thing does not cost a lot, at least for the context of who's going to use it. A simple thing tends to have a high performance or high value for the cost, right? Ultimately, everything simple also has a function. It must do something, and that function that it does, it must be worth the cost, right? It's actually got to do something. It can't just be useless. It's got to do something. So those are kind of the obvious 2 that you might think of yourself. But then he poses 2 other that I think are less obvious. He says that they must be reliable and predictable. And the easiest initial way to think about this is if something is unreliable and unpredictable, that tends to be a property of complicated things or complex systems. So a simple system should be predictable and reliable. And then the last one is simple things tend to be able to act as building blocks, or they tend to be stackable. Tend to be able to take them and put them together somehow. Simple things tend to be able to be repurposed easily so you can build other things with them. And this very much goes to that third property of reliable and predictable, because you wouldn't want to really build on top of a simple thing that was unreliable or unpredictable. So those are the 4 properties. And, but what we really, to make them useful, is you kind of want to think about them more in a framework sense. Because if you've got a framework, then you can do fun things like evaluate a process, a tool, a technology, whatever it is, against these properties, to be like, how simple is it? Or then you could use these properties as a guide, right, for creating or changing or optimizing something to make it simpler. For instance, to make it scale better. And you'll see I renamed the building blocks stackable into composable. I felt that was just a better word for the tech that we would use in technology. So I've leaned towards that word. So for each of these properties, what I'm going to do then is going to try and get a deeper understanding of how to interpret them. So I'm kind of going to deconstruct them a little bit in order to evaluate them, give you different ways of thinking about them. So the goal being, if you've got numerous avenues to explore with each of these properties, then you can use those avenues to help evaluate or optimize something for simplicity. So I'm going to start going through each of these properties and sort of thinking about the ways you might use them or think about them. So the first property is cheap, right? And this is pretty straightforward, right? Something simple must be cheap. It's got to not cost a lot. And intuitively, this is what people think about when they are asked to make something simpler. They often make it easier. By making it easier, you're saying, I'm going to make this, it's going to cost less for you to do. And how do we evaluate the cost of something? Well, there's lots of different ways, right? Like if you wanted to make something simpler, you make it so it takes less time to do, takes less resources, takes less people, less effort, less knowledge, less training. But of course, you can't just keep on making things cheaper, indefinitely at least. There is a limit to how cheap you can make something. Once it is too cheap, chances are you affect the value of what it is you're trying to work with. Which brings us to the next framework property, which is value. So for this framework property, we want to evaluate the value of something. But how do we do that? I think there are a couple of different ways. First and foremost, something must have a function, so it has to be useful. What does useful mean? This is more than probably any of the others. I think you really need to understand context in order to know if something is useful, right? So who is it going to be useful to? So a stamp collector, for instance, has a certain use for a stamp. You might send a letter. You have an entirely different use for a stamp. Useful is going to be about, where and when. A hammer is a useful tool, but not if you need a screwdriver, because you can try to screw in a screw, right? So that matters as well. Why can be important to evaluate for use, right? So if you're part of a sports team, you might be part of that team because you want to win everything, and that's how you get use out of that experience. Or you might just do it because there's a camaraderie amongst being part of a team and playing with friends. How much is something useful? A ladder is great if you need to get on the roof of your house, but that same ladder that lets you get up that high is going to be pretty useless if you need to change a light bulb in your house, right? It's too much of value if you're thinking about it in that sense. So one way we can evaluate the value of something is by trying to understand how useful it is. Now, but there are other ways. For instance, value can be thought of by how convenient something is. So something can offer more value if it's available in more places, at more times, for more people, in more variety, for more purposes, and in more ways. And yet another way to evaluate or optimize value is by creating different output at different costs through offering variety. So just like with cheap, we can't just keep making things cheaper indefinitely. You can't just keep on offering value indefinitely, because inevitably that makes something more expensive. And when the cost is too high, that means that less people are going to want to use it. Now, for some people, they want that best value and are willing to pay the cost. So to satisfy everyone, you offer value for different audiences at different cost points through a variety of things. So Lego is a good example of this, right? This Millennium Falcon set looks awesome. If you were into Lego, you would probably want to get that. But not everyone's going to want to spend the money on that, right? It's pretty hard to justify the expense. That cost-value ratio just probably isn't 100% right. But don't worry, there's probably a Millennium Falcon for you, because then there's a slightly cheaper version that's still kind of cool, bit cheaper, but maybe that's still too expensive. Then there's a slightly less version, slightly lower cost version, slightly fewer pieces, still cool, bit smaller. Maybe that's good for you. Then you sort of start getting a bit lower down, probably only offers really value for the kids, but it's pretty cheap to buy. And then if you really are tight on money, you can pull together your own one for virtually nothing. Anyway, we think about value. To think about value, you can think about how useful something is, how convenient it is, and what different varieties it can come in. You can then evaluate or optimize something using this framework property of value to drive your making something simpler. Okay, so it's cheap and value. The third property is predictable, reliable. This is, of course, two properties, but the TED Talk treats it as one property, so that's what I'm going to do as well. So I sort of interpret these. I sort of was thinking about what do these really mean. So predictable for me means it meets expectations, really of all audiences. Something will have no surprises. People who use it will know what to expect. It does what it says it's going to do, and it does the same thing that it did last time. These are the qualities of something that's predictable. Reliable, on the other hand, means it's going to work on given a variety of input. Maybe not any input, but just in the context of your situation. Reliable also sort of invokes for me the idea of trust. People using something like your process or tool or technology, they need to be able to trust that it's going to work the way it should. So a great example of this is an old marketing campaign for this varnish here. And their marketing team was saying, hey, it does exactly what it says on the tin. And that was like their clever way of saying, people, this is going to be predictable and reliable, and you can trust us. Of course, not everything that you have ever experienced has been reliable in the past. I certainly relate to the issues of using Microsoft Word in that way. So in terms of the framework, how would you evaluate predictable and reliable? Well, those two things by themselves are really like important and essential. However, my interpretation is really that there are probably other properties that also fall into this category, right? Because there's sort of the idea of properties that'll harm adoption of this thing that you want to be simple if they're not there. So I can think of another property. I could take something like duration as a property, right? Something simple probably doesn't take ages and ages and ages to run and do its job, right? That would seem like a property that you would also want. And there are probably other properties as well. So I personally tend to think of this sort of section of this framework of predictable, reliable as being about removing barriers to adoption or trying to evaluate how usable something is. Now, focusing on predictable and reliable, can't find my mouse. Focusing on predictable and reliable is essential, but I wouldn't restrict evaluation to just those properties, right? If there are other properties that you think affect how usable something is. And then the last property of the framework is composable. So we want the output of a process or a tool to easily be used as input to something else. And when something is composable, it really can offer value in potentially ways that no one has ever envisioned, right? And that's the property of something simple. People are going to take it and use it in ways no one else had ever imagined. And technology has lots of examples of this already, right? So we had a Wordle competition at work. I kind of guess that whoever came up with Linux grep commands and Linux piping commands never thought that it would be used to solve Wordle competitions when they were designing it. Or whoever came up with the creators of Minecraft probably never thought, you know what someone might do one day is build a working game of Pong inside the Minecraft world. And just generally, right, software in general, software ate the world. So, you know, all of the open source libraries, all the APIs out there, it's really a big pick and mix of composability, right? You go out and you grab one, you grab something else, you use your OpenAI APIs, your AWS APIs, and you go and build crazy things that people never imagined were possible. So that's great. But in terms of the framework, it is more difficult to sort of say, well, how composable is something? How do you actually measure that? How do you get a feel for that? Because you don't really know how it might be used at the end of the day. But I think you can evaluate or decide whether something was designed with composability in mind, simply by looking at how easy it is to sort of use the output as input to something else. And, you know, these technology examples sort of show that. They were really designed to use in ways that, you know, anything could happen with them. So that's the framework we have for simple, right? In order to increase the adoption of a process or tool or technology, you have these 4 properties, and I sort of understand the goal of each as being to minimize the cost of the input, to maximize the value at a given cost or a range of costs, to maximize ease of use, and to maximize the output being able to be used as input. Now, it's worth recalling what I previously said about context, right? It's really important when trying to understand simplicity. And so context can't be ignored when you start looking at this framework. And sort of, despite me generically deconstructing these properties, in practice you have to do this in a specific context. Because context is so important, I've sort of added a line to the top of the slide there about what the goal of my talk is today. And it's sort of on top of every slide pretty much from now on, so we can always remember that's what we're doing. So we briefly covered what was in the TED Talk, covered how we can use these properties as a framework, but this is a talk about threat modeling. But you thought I'd never get there. And so that's so that's the context that we want to explore with regards to this framework for simplicity. So now I'm going to discuss and evaluate each of the properties again, but really in the specific context of threat modeling. And this supports the goal here, right? Because we want to give ourselves ways we can minimize cost and maximize value in regards to threat modeling, making it simpler, thereby increasing adoption. So, back to our first property, cheap, in the context of threat modeling. I mean, we all know we want the input to the threat modeling process to be as cheap as possible. No one wants to force teams to do more work than they should when they help out with a threat model. So we need to think of the ways that threat modeling introduces cost to the teams you work with and evaluate how that could be minimized, for instance. So people is the first one that I would suggest. How can you minimize the people cost of working on a threat model? So I suppose in an ideal world, you'd probably just work with one other person to create a threat model. That's probably about the minimum you can do, but you sort of have to think about which person you're going to accommodate that for. Because if it needs to be the most senior person in the team, that sort of has a cost associated with it, doesn't it? Because their time tends to be the most valuable time that you can get of someone because they're a senior person. So you can think about cost here in terms of can you have a threat modeling process that works with the more junior people in a team, but maybe more than one? Would that actually be cheaper overall for an overall cost to a team? And that sort of brings you on to time, right? And when is an important question for understanding cost. When will you do the threat model, and when will that have the least impact on a team? There's usually never a perfect time, but there's usually a better time in terms of opportunity costs of spending time threat modeling for the team, right? So like, don't ask them for a threat model just before they're about to publish a new version of something. That would be like a huge cost to them. There's how long it will take to do the threat model. Largely this is defined by kind of how you choose the threat model, what process you actually decide on. You could time box it to a single meeting, a single day, or something like that. You could do it what I would call a sprintable effort, so something they can pick up and do in one sprint, if that's how they work. Or it could just be a task that that goes over several weeks as sort of a side task to their normal activities. There isn't really a right answer to this question, right? It's more about how can you make the threat modeling process align best with how a team works, thus minimizing their time cost. And then there's knowledge cost, right? How can we minimize the knowledge cost of populating a threat model? And there are lots of different knowledge costs that we impose on people when we threat model. There's process knowledge. So how much cost is it for them to understand the process? Like, how many meetings are required? What are the ways of working? How much cost is it for them to figure out how they're going to incorporate threat modeling into how they work already? That's another cost. There's background and training knowledge. How much cost is it for them to familiarize themselves with threat modeling documentation, or to familiarize themselves with semantics or the security language that your process uses? What about the cost to familiarize themselves with any tooling required? Then there's knowledge types of cost. Then there's training, sorry. No, what have I done here? Technical knowledge is what I mean. So then there's a technical cost. So there's a cost to like creating a diagram, if that's part of what you need. And then is that in a tool that they're familiar with? There's a huge cost of changing that diagram as well. What are the costs in terms of them needing to know about all the different parts of their system, how those parts interact, how data assets flow through those systems, and how much detail in terms of implementation do we need them to have for understanding cost? And then finally, there's security knowledge, right? So what is the cost for them trying to really understand what it is that they protect? Or how much do they need to know about the security controls that they already have in place and how those work? I think what's key here is in getting to understand the processes for the people involved, right? You've got to really understand how it is that people work. So when you're evaluating ways to make things cheaper, you're doing it in the context of what makes it cheaper for them, and not so much what makes it cheaper, say, for you if you're creating the threat modeling process. Because some teams have great docs. Admittedly, not many teams have great docs, but if they do, then that's going to influence how much the information gathering cost is. Some teams will have done threat modeling before. that'll influence the cost of just understanding the processes. Some teams will have focused a ton on security. They'll really know their controls in and out. For them, that cost is going to be minimized. And then some teams will have team members who have worked on the system for years and years, and they just know everything really easily. Other teams will have had some sort of churn, lost a lot of tribal knowledge about how their systems work. The cost for them will be higher. And other teams will inherit systems and basically know nothing about how it works. And for them, the cost can be really big. Practically speaking, you can't, of course, change the way you threat model for every team that you work with, but you can try and bend it to make sure that it's as applicable to them as possible and to minimize their costs. So then we move on to value in the context of threat modeling, right? So I think, like, first and foremost, threat modeling needs to evaluate. Threat modeling has to do a good job at finding relevant and actionable threats. But how do you evaluate what are relevant and actionable threats? Well, the first thing is to understand the process. It must focus on finding what is important to the business, right? And in what way. So some businesses, like intellectual property, secret recipe, for instance, is going to be super important to them. Other businesses must hold data that must never change or only change in really specified ways, like a medical record. Availability is crucial if you're an airport, for instance. And if you're into journalism, trust might be the value that you think is most important. Understanding what is important lets you define what you want to focus on finding, what sort of threats you're most interested in. I call this choosing a security model, or choosing the security properties that you want the systems to have. So common choices are things like stride, spoofing, tampering, repudiation that you may have heard of before. Or you could choose a MITRE ATT&CK framework, or MITRE CWE, or some other well-known list of security properties that you think your business should have, or some combination of those. The point is that at the end of the day, you need to be able to justify what you choose as being, like, most relevant to the business. But of course, the more security properties or threats you consider, the higher the cost to produce a threat model. And one of the best ways, in my opinion at least, to reduce the cost of producing a threat model is to use a simpler security model. By that I mean sort of focus on fewer security properties. I'd say every security property that you sort of decide you want to evaluate and include in your threat model, it really acts as a multiplier for the cost of producing a threat model. And so removing properties can have a huge effect on the amount of cost it takes to produce a threat model. But of course, you need to remove things in such a way that you don't have a huge impact on the value that you get out of the threat model. So there's a real trade-off there to consider. So the value property is very much focused on delivering knowledge of threats to the business. Predictable, reliable here is slightly different. Its focus is to remove barriers to adoption, right? Having a process that deliver what teams expect and that they can trust to do a good job and not waste their time effectively. So what we really want is for our threat modeling process to do what it says on the tin, right? So what are we going to put on the tin? Well, let's think of some ways that we could think of things we could put on there. So in terms of reliable, it should be tech agnostic, right? It should work with all the tech in the business. You don't want to tell a team, I can't threat model you, we don't support your tech stack. And the analysis you do should be a high quality analysis that works well for any part of the business, maybe not just technology, maybe marketing as well. Whatever you need to cover, it should work in that situation. It should be repeatable, right? The same input should have the same or similar output. That's probably not going to be 100% true all the time, but basically, if you are doing the same process and you get different results each time, you're probably missing something. And then you have the stakeholders, right? The output needs to keep stakeholders happy. It's more work if you need additional processes to keep other stakeholders happy. Then we can think about predictable, right? What are the properties here? So timing. A threat model should be done at the right time. Too early and the threats are too generic. Too late and the cost of change is too high. You have scoping, so a threat model should cover exactly what it needs to cover in terms of what's in scope and no more. You don't want to produce a bunch of threats that a team doesn't own and can't really do anything about. Threat model should cover everything that you define as being in scope, but you don't want to miss anything, right? That means you'll miss threats. It should be a certain level of consistency in how you capture information. You don't want to be able to produce a threat model and hand it to someone and they can't understand it because it's so inconsistent throughout. All the required information should be there. It should be complete. Again, you don't want to hand over a threat model to someone to someone and where half the information is missing. It should be correct. The data formatted inside the threat model should be correct. Otherwise, people won't be able to use it. It should be compliant. A threat model should respect company standards for something like documentation, for instance. Otherwise, it's limited in use. Volume, so the number of threats it produces should be limited in number, right? Because we've all had tools output so many threats that people just sort of get snowed under and overwhelmed by it all. And then the actual output of the threat model, of the threats and follow-up actions should be the same across threat models, so people can do planning with the information that they have, and they're not going to struggle. Now, all this sounds like a lot of little things, perhaps, but they all sort of add up, and they present a threat modeling process to the teams that you work with that says, hey, this process has been thought about. It's been defined, and it's been aligned with company requirements, and generally it just comes across as a bit more professional. And the more the entire process that you create is presented as usable, as meeting expectations, as being trustworthy, then the more likely it is to be adopted. Basically, there's just less reasons for any teams you work with to sort of say, no, we don't want to do this. And then on to the last one, composable. Now, composable in the context of threat modeling is about evaluating the way the output can be used with other processes, right? Now, while the output might be used in ways that we can't envision, and that's kind of the purpose of this property, there's still lots of ways we can envision that a threat model output could be used, and so you can focus on optimizing for those, really. So, for instance, can you compose the threat model output to get a larger view of threats of the system? Can you use the output to enable other security processes, right? The output of threat modeling should feed into something like security testing. Does the output help governance processes to keep track of the coverage of threats and risks across the business or against an inventory of systems to make sure you have coverage? And does the output, can it be formatted to specifications that are required for external auditors or other partners? And can you use the output for creating metrics, right? So maybe you could measure which controls are most heavily relied upon based on how commonly they mitigate threats, or you could come up with some sort of threat score based on the number of threats and controls the system have and compare that to maybe some average across the company. Now, to be realistic about this, just because you have the output and you expose any data in a threat model, it often is a lot of work to make that data useful. Moreover, because a lot of threat modeling data can be free text and free format, that makes it even harder to use necessarily to pull out relevant information. I guess I'm hoping this whole machine learning thing works out and solves that problem for me, but I'm not quite sure it's there yet. What I would be, the takeaway here would be try to optimize the output for composability. If we do that, we can make threat modeling really a foundational activity of your security ecosystem. That's really what we want to get towards. And that will ensure its continued adoption and relevance. Now, if you haven't guessed it, and you're someone who does threat modeling, today's talk isn't really about how to make threat modeling easier for you. It's kind of about the complexity required to make it simple for those who are actually going to be, you're going to be working with. And the idea behind this framework is really to try and help tame some of that complexity, to add some structure to our efforts to produce a simple process that will actually scale. So let's try and condense some of what we've covered so far in interpreting this framework in specifically for the context of threat modeling. I can sort of define a specific goal, I think, for each of these properties that we're dealing with. So for the property of cheap, really the goal is we want things to be as easy as possible. We want to reduce the cost of threat modeling in terms of people, time, and knowledge. For value, the goal is really deliver relevant and actionable threats. We want to make sure the threats that we output align with what the business cares about. For predictable, reliable, we're really talking about removing barriers to adoption. Process has to be usable, right? And we have to look at the ways that it might introduce any friction and look at ways of making that as smooth as possible for teams. And then composable, we want threat modeling to become a foundational activity. How can we make the output of threat modeling as useful to other processes as possible? Because this will increase adoption, which will then help us focus on making the process more scalable. So sort of enough with the theory, I suppose. Is any of this useful in practice? Sort of like, it was actually how well the framework explained, or at least evaluated, some other common approaches to threat modeling that really quite succinctly, made me sort of highlighted quite succinctly why I had struggled with some other threat modeling processes that were quite common. And that actually made me think, well, this is going to be quite useful because it actually captures some of the issues that I've seen in other processes. So I wanted to sort of show you how I have evaluated some other common approaches to threat modeling against this framework, sort of better understand how well these approaches scale. So first I wanted to cover was sort of brainstorming, right? When you threat model via brainstorming, you're basically saying you're going to get a bunch of probably senior people into a room for an hour or a day or something like that, and you're going to draw up a picture on a whiteboard, and you're going to be like, right, here's the system, let's start thinking of all the threats, and you're going to sit down and try and have a reasonable conversation and not go down too many rabbit holes. Try and think of all the possible threats you can. And if you try and evaluate the pros and cons of this approach, it's certainly got some pros, right? Like, it tends to be one of those processes that creates novel threats, like probably no other approach can. But then it has some cons, and the ones that I would call out mostly are basically it's really not a very repeatable process. I think if you did it twice, you're very unlikely to come out with the same set of threats. You might think that's a good thing, but I think it's if that makes it unpredictable, right, and unreliable. And for me, then that sort of fails the criteria in this framework for, is there something simple that will scale? Now I should say, and make it very clear, right, I'm not saying don't use brainstorming as an approach to threat modeling. I'm not saying that at all. What I'm generally saying is I think when you evaluate it against its framework, it doesn't really meet the criteria for something that should scale, at least in terms of being something simple. I do think, though, if you understand the context of when its pros outweigh its cons, and use it in the right situation, so for instance, if you are pressed for time, if you need to do a one-off exercise, or you have strong commitment from the people involved, then I think it's a great solution. It really has some pros to it. But does it scale across the company? In my experience, I don't think it does, but your mileage may vary. And then the other one is the Microsoft Threat Modeling tool. Again, I'm not saying don't use the Microsoft Threat Modeling tool. In fact, if you look at the table, right, it's got more pros than it does cons. So I think it sort of comes out okay. I think I would call out two things about it that I've always struggled with in the past and sort of align with the framework, right? The first is the cost aspect of getting people up to speed with using it, understanding how the diagrams work, understanding some of the security terminology that's used, explaining stride to them, things like that. And the other one is how much the noisy output of it, because it produces so many threats, that really lowers the value because there's just so much, the signal to noise ratio isn't really correct. But to be honest, I think the Microsoft Threat Modeling tool is a great place to start your threat modeling journey. I just think after a while, some of these issues, most notably the sheer number of threats it produces, not all of them particularly useful, makes it hard to want to use it to scale threat modeling in a broader sense. So again, it's just like the right tool for the right job, perhaps at the right time. Okay, so you're probably asking yourself, this guy has spent a lot of time thinking about threat modeling. But there's a reason for that, because I actually decided to create my own approach to threat modeling. I thought, I've tried several other approaches and haven't really got what I wanted out of them. So I wanted something that I thought was going to be simpler and more like developer friendly. So I want to talk about some of the design decisions that I made when I created my own process, and how they align to this framework. Really, my goal is to demonstrate with my own process as an example the sorts of decisions that you might make, hopefully to create a simpler, more scalable threat modeling process in your own situations. The examples I give will be based off my experience designing an open source process and tool that I call Threatware to help with aspects of this process, right? And I should make it clear that a lot of the design decisions I made before I had even heard of these 4 properties and this talk on simplicity. But actually it was the alignment between my experience and the framework that made the framework really stand out to me, right? I got this immediate confirmation that this framework was going to be useful because it sort of very aptly captured the rationale behind many of my decisions that I thought, well, maybe this is good rationale, maybe it's not. But when you see someone else come up with it and explain it kind of on your behalf, you're like, well, this makes a lot of sense. So I'm going to talk about these design decisions. I'm not really going to talk about how to threat model using this approach, right? You can read more about that on the website if that interests you. And really, really importantly, I'm not claiming that this approach is going to be the simplest you've ever seen. I'm not saying, hey, it can't be improved. And I'm not really saying that any of the decisions I made would necessarily be something that you should also make. As I said before, right, context really matters. And my decisions were made in, to solve the problems I had in the environment that I was working in. And you should view this as more of a case study, really. And if you benefit in other ways, that's great. So in terms of the context that I had, right, like many of these design decisions were made at a sort of a startup type company. They had like a couple of hundred devs. The software process was heavily audited and the threat models were audited as well. And most of the tech stack was using things like microservices. But I can talk about this process and ways in which I made design decisions around the cheap property, or the goal being, how did I make things as easy as possible? So learning a new tool has a cost. This can also lead to vendor lock-in. So this process that I come up with, where you create a threat model using Google Docs or a Confluence, right? Kind of everyone knows how to use those, so there's no real burden on people to use those tools. Creating a diagram in a certain format, that can be really costly, especially to maintain that diagram as the system evolves, right? I hate changing diagrams, it's such a mess. Now the threatware process that I come up with, it says, you must have a diagram, but really any relevant or mostly accurate diagram is going to be fine, right? The diagram isn't the main analytical tool that's used to capture threats. Developers shouldn't have to be security experts, so using security-specific terminology, something like stride, can be a real cost to them. It's kind of hard and difficult, if not impossible, to remove all security language, so that's clearly not going to work, but you can try to minimize it for developers, I would say. And in this process, they only really need to understand confidentiality, integrity, authentication, and authorization. And to be fair, authentication and authorization can get incredibly complex in some situations, so it is still a struggle. But the ones that you do have to explain, you try and explain in simple terms as possible. So when I talk about confidentiality, I really just talk about, hey, does something have read access to some data? Or if I need to talk about integrity, I really just talk about what has write access to this data. And read and write access is something developers, they just understand that already. A security model for threatware is chosen just to elicit design issues, right? If you want other threats, they can be captured, but there's lots of other tooling for doing things like vulnerabilities and stuff like that. So we're going to just focus the process on finding design issues. It's going to be threat-focused and not risk-focused. What do I mean here? Well, when you consider threats and risk, I would argue the information you need to gather to evaluate risk is more information than you need to gather in order to decide if a threat exists. So this process really only asks for enough information to determine if there is a threat. You may need to gather more information to determine what the risk is, but if you can minimize costs by only doing that in the circumstances where gathering that information is actually relevant to finding out the risk of something, and you're not gathering it broadly for everything when you wouldn't use it. The bigger the scope of a threat model, the more complicated it becomes. This is what I would say. And so the process here really encourages many small threat models over a few large ones. It's really rare that any system that you ever threat model is completely unique, right? Like this process really encourages you to generate templates with shared information, like the context and some threats and some controls. So teams don't need to start a threat model from scratch each time. So if one team threat models a web app, you can take that, you can make a template from it, so the next team that builds a web app, they can kind of start with this basic template for what a web app threat model should look like. That can lower their cost as well. And you lower even more by sharing threat models, right? Teams learn best from examples. This is a big one, right? And because the format is common to all threat models, it's very easy for them to take one and copy and use information in other threat models. And that really accelerates their process, lowers the cost of creating a threat model. We have detailed documentation for the threat modeling process, so teams can sort of self-serve and solve their own problems without the need for security, and that lowers the burden on everyone. And then lastly, we have system knowledge, not security knowledge. Again, developers shouldn't really need to be security experts. expecting them to be is a huge cost on them. So this process really just focuses on asking, when you populate the threat model, you're populating it with information about how the system works, really. The idea is that if you ask for the right information, it really, the threats can become apparent. And this way, you don't need developers to be security experts. So there's sorts of design decisions that sort of align with making it cheap for the threat model. For value, well, you recall the goal here is for delivering relevant and actionable threats. So really by just focusing on a few design issues related to access control, so access to systems, authentication, authorization, access to data, confidentiality, integrity, this really reduces the volume of threats, right, and ensures the threats are going to always be relevant. Even with a focused security model, evaluating security properties for every sort of permutation of component and data, that can lead to an explosion of threats. So this threatware process allows you to express threats in aggregate, and that greatly reduces the number of resulting threats in the system. That makes the review and comprehension of threats easier and more meaningful. Now this issue of the permutation of components and data mean that some threats might be missed. So the threatware tooling that exists solves this by leveraging the document structure to detect missing permutations, which then leads to some assurance that threats haven't been missed. And lastly, approvals, right? So like I said, I think it's a good thing to be able to copy content from one threat model to the next threat model if it's relevant content, but you only want teams to do that if you're copying high quality content. Otherwise you get sort of copying junk, you get sort of the Stack Overflow of mistaken answers propagating. You can solve that by having threat models being approved. That means that the threat models you give for people to copy have been approved, you know it's high quality content, and then copying becomes a good thing because people are copying high quality content from one threat model to the next. Okay, the third property, predictable, reliable. In terms of threatware, remember the goal here is remove barriers to adoption. So this one I call Conway's threat model, right? If your threat modeling process produces threats that a team can't solve themselves, that's sort of a barrier to adoption of the process. No one wants that kind of thing. If you've heard of Conway's law, it says that your software will mimic the organization structure of your organization structure. Meaning, quite often when you threat model, you want to decompose the system you're threat modeling to threat model smaller bits, chunks at a time. So it turns out if Conway's law that says your organization structure maps your software structure, you can end up threat modeling your different teams in your organization, and that's one way to threat model the different parts of your system. What that means, if you just threat model individual teams and what they build, you'll only come out with threats that are relevant to them. And that way, you can offer this value to them. Or you won't run into this problem of threats that they can't control. A structured document, so if the content of the threat model is unpredictable, that would be a barrier to adoption. So by using a structured document, how and where the data is captured is the same for every threat model. So teams know exactly what they need to do and what good looks like. Now, teams can't tell if the content is incorrect. That would be a barrier to adoption. So just using a structured document, that doesn't really mean the information populated will be consistent and valid. And initially, this was a really laborious part of this process, right? Because trying to manually evaluate that teams are doing the right thing is really difficult. So to solve that problem, I wrote a tool that parses the threat modeling document and validates different aspects of it, right? So now teams can self-service verification, and there is a consistency about what is expected from them. And then lastly, if the follow-up actions from threat modeling don't align with how the team schedules work, that will be a barrier to adoption as well, right? So any work that's identified off the back of this process really just becomes a link to a ticketing system. And that way, teams can consume threats and the remediation advice using the same ticketing system they would use for consuming any other type of work. Okay, so the final property is composable. Some threatware examples for this one. Again, the goal here is to make it a foundational activity. So we want composable scopes, right? So a process that encourages lots of small threat models, that runs the danger of having threat models that overlap with each other, and that would just be extra work. So to avoid this, you can configure things so that every component is only in scope in one threat model. And this means that the set of threat models can then be composed together, making them complementary to analyzing the security of a larger system. Of course, the output will contain metadata and components of assets, so that again is a way of having that data available for other purposes. Again, we call out controls, so if you capture all existing security controls, that becomes a useful reference for other security activities like security testing or penetration testing. Clearly tells them what controls they need to test. Now, although the teams produce a threat model in like a Google Doc or a Confluence page, the tooling converts that to a JSON or YAML representation, right? Meaning that most of the data is actually machine readable. And then that JSON and YAML representation is actually stored inside a Git repo, and we leverage that as a version control system, right? So each approved version of a threat model is stored in the repo, making it not only convenient to access the data of the threat model, but also any previous versions of that threat model as well. Naturally, it would be remiss of me not to call out what are some of the downsides of this process. Well, it certainly works well for systems that can be easily decomposed. If you have a huge monolith, that's normally difficult to decompose, so it's harder to use in those situations. If you just want to threat model a very specific feature and you haven't threat modeled the system already in general, it works less well there. Some situations might require you not to capture all existing controls. I would always be a fan of capturing that, but some businesses might not need it. And of course, using a document format means controlling the format of the fields really only can be done if they go through the validation and use the tooling. Obviously, if you were threat modeling inside an app and you get that real-time validation, that's sort of a better thing. And then generally, like, I have on purpose simplified all the security model, right? So I can't really find all the super novel threats. That doesn't mean you can't add them to the document, but then that just becomes an activity for the security team to do in conjunction with the team that you're threat modeling with. Okay, so I made a bunch of design decisions for this threatware, and I contextualized them in the framework. Hopefully you can see how using this framework in the context of threat modeling gives you a means to evaluate, review, or even optimize your own threat modeling approach. But I wanted to leave you today in the spirit of the talk with a simpler set of questions that you can use to evaluate your own or other threat modeling approaches, something that will hopefully give you an easy place to start. So for each property in the framework, we can ask ourselves some basic questions, right? So in terms of cheap, we want things to be as easy as possible. Question is, how can you minimize what people need to know about security? I think you'll get a lot of mileage out of just minimizing that aspect. And how can you minimize what information they need to provide? For value, how do we deliver relevant and actionable threats? You ask yourself, are the threats that you project, that you find as part of your threat modeling, do they offer value to people? What can you change? How can you change your process to offer more value? I'll say this, and it might be a bit controversial, and definitely not applicable in all cases, but considering the trade-off between cost and value, I would more often than not lean towards minimizing cost at the expense of value. It's my opinion that a threat modeling process that people actually use will always be more valuable than one that doesn't get used at all. And the last two properties, predictable, reliable, right, remove barriers to adoption. I like the one here where you think, if the threat model was done twice, would I get similar results? That'll tell you a lot about how predictable and reliable your approach is. And then, can the output of threat models integrate easily into teams' existing processes? This is saying, like, are you aligning with the teams you're working with in ways that make their lives easier? Then lastly, composable. We want threat modeling to be a foundational activity that other activities can rely on. So these are mostly security focused, right? Can you compose your threat models together in order to get a larger view of the security of a system? And then does the output of your threat modeling really work well and feed into other security activities? So a set of simple questions here hopefully gives you a place to start in order to look at your own threat modeling process or other ones. And that's all that I really wanted to cover today. So in brief summary, I think simplicity is really the key to scaling probably just about anything. But simplicity is hard, right? It sounds like, this is going to be a talk about how to make my life easy. It's really about how to make your life more difficult in so many ways. It's really not just about, you don't get to simplicity by just doing something really basic. It's often the journey to simplicity is you end up with something quite complicated, and then you work at, hey, how can I strip things out, pull things out of this, and be left with something that offers value at the right cost point, but is also really usable. And of course, you can't do any of those decisions or any of that work unless you really truly understand the context in which you're working. And in the case of threat modeling context, then if we interpret the 4 properties like this, we'll hopefully get a threat modeling process that is more scalable, more accessible, and ultimately more successful. So thank you for your time. I'm happy to take some questions. I'll also say, if you haven't heard of the Threat Modeling Connect, it's a forum for threat modelers where you can ask any and all threat modeling related questions. And also a lot of the content I covered here today is in a blog post on that website. But thanks again, and yeah, happy to take any questions. No questions? Oh, I see a hand.
In your experience, should also non-developed organizations do threat modeling, such as business operations, or even should finance people consider their finance systems and processes somehow?
So the question was whether non-dev parts of the organization should consider threat modeling. I'm not sure how mature I think it would be in those aspects. I would say they probably have their own areas of risk assessment that they should be doing and understanding what works for them. I think some of the ideas are certainly transferable to other domains. I'm not sure, as a threat modeler for technical systems, I'd want to go over there and start telling them how to evaluate their things. So I think it is essential to do something. I'm not sure that as a threat modeler I'd try and tell them how to do stuff. I'd obviously give them a hand if they wanted it. But yeah, I'd try and help them however they wanted to be helped, rather than sort of say, hey, you should be doing threat modeling. Any other questions?
I did a quick Google search to see like your threatware. I didn't find any resources. Is there anything online as well for your?
Yeah, it's you go to.
Was probably part of this, but I didn't.
Too slow, eh? Yeah, if you go to threatware.readthedocs.io, it's right there. Any other questions? Okay, thanks very much.